We've spoken about R values and correlation. Today we're going to look more closely at the difference between two things that are correlated versus causation, having a cause and effect relationship. While two events can be related, that there's a correlation, it doesn't necessarily imply that one thing causes the other thing. So, in other words, there's a cause and effect relationship. If action or event A occurs, that causes event B to happen. That may be true. The point is that it's not always true. So when we look at a scatter plot, even if there's a very strong relationship, that R value we spoke about, right? It doesn't necessarily mean that this is a cause and effect relationship. Very often there's some third variable acting on the two events, and that variable is what causes those things to follow that same pattern to occur. Such is the case here. We're talking about ice cream sales and sunburns. These two things follow the same pattern. They're correlated. If we were to graph ice cream sales over the months of the year and sunburns occurring over the months of the year, you'd see that both of them are high and low at the same times, right? Summer, maybe. So the fact is the two items, ice cream sales and sunburns, are correlated, but they're definitely not causing each other. Higher ice cream sales does not cause sunburn, or the other way around. There is a third thing. It's sunny out. When it's hot out and sunny, that's the thing that causes ice cream sales to go up or more sunburns to occur. Let's look at this scatter plot. On the x-axis, we have the number of pirates that exist. And on the y-axis, we have the global average temperature. It's in degrees Celsius, but that really doesn't matter. The different years, we can see the number of pirates is going down as the temperature goes up, or the years increase, right? So does that mean that as global warming happens, the number of pirates decreases? I mean, it's almost ridiculous to think of, right? But there's a clear relationship here. We've put two random things on a graph, tied them together with time, and made it look like there is a cause and effect relationship, when in fact, there's no relationship here. Here's another one that might be even clearer to you. This graph makes it look like these two events, Google searches for the phrase "that is sus" and Lululemon stock price. This graph shows a very close relationship. You can see it, right? But look at what these are. Let's use our brains, some logical thinking. These happen to follow the same path, but one doesn't cause the other one. The bottom line is that things can be correlated. Events can have some correlation, but that does not imply causation. If we look at ice cream sales and shark attacks over the course of the year, I bet you can guess that those will go up or down at about the same time. But does shark attacks cause ice cream sales to go up? Or does an increase in ice cream sales cause more shark attacks? No, of course not. There's a third thing at play here, and that's the fact that in the summer, it's hot. People tend to buy more ice cream, and they're in the water. So there's probably an increase in shark attacks just for that reason. They're there. Let's practice this. I have here 8 correlated statements. What I want to know is if they're causal, which is another way of saying, is it a cause and effect relationship? Does one cause the other, or are they just correlated? Pause the video and try these now. How did you do? I put 2 forms of the word because you'll hear it either way, and I want to make sure you understand it's the same thing. So in this first case of each term, you will either see the word correlated or correlation. You might hear causation or the word causal. So look at the root of the word. A lot of things are correlated. If you look, there is a relationship between many events. It doesn't mean that one causes the other. And so you have to think carefully in each case about that. Let's practice with some of this logical reasoning. Students conducted research for their statistics projects to model the set of data that compares the number of TVs per person in a given country and the average life expectancy in the same country. They calculated the R value at 0.87. I want you to think about that information and discuss the type of correlation it is, what that R value tells you. The students concluded that the more televisions you have, the longer you will live. Is that a correct conclusion? And give me your justification, why or why not. And then answer the question, what might explain the high correlation between the number of TVs and the longer life expectancy? Is there something else that's contributing to that? If so, what is it? What could it be? You're going to discuss these in class, but I want you to think about these carefully. The second practice problem I have for you talks about the number of facial tissues used and the number of students with colds at a school. The number of students with colds is along the x-axis, and the tissues used is along the y-axis. So if you'll answer the questions here, we'll discuss them further in class. These are on your slides linked in the materials for class today. Which statement can be concluded? So they're asking which one is true based on the data, A, B, or C. And then are we describing this as a correlated relationship or a causal relationship? You decide, and we'll talk about that in class.